Okay, so as I was saying, um, yeah, so the function just converts a string to a date. Could also convert a numeric value to a date, depending on the format you have it in. So it's left to you to look at the format you're trying to convert and use the appropriate string. So for example, I use the appropriate function, sorry. If I wanted to convert this number to a date, we have 2017-1702. So that's the year, day, and the month. And then when I run this, it converts to a date. Alternatively, if we had 2017 02 17, that becomes the year, month, day, and when I run it, same thing converts to a date. So you could also create date times using the same idea from strings. So you have a string, and it also contains a time like this. So this is a string, it also contains a time. So you could use the year, month, day, you add an underscore, and then hour, minute, seconds, as the case may be. So this year, month, day, hour, minute, seconds. If you run this, it creates a date time. Same thing. The idea is basically the dates will come in many different forms. So it's left to you to know the functions that are available and decide what function will give you the desired output. So in this case, I have a date that comes in a month, day, year format with a date with a time as attached. So I know I'm going to use the MDY underscore hour minute because that's what's there. There's no second. So if I run this, it gives me a date time. So that's one example of how to create date times using the Lubridate package in R. Another example is you can combine multiple individual elements. So for example, if we look at this flight data set, it contains a year column, a month column, a day column, an hour column, and a minute column. So it's possible you receive a data set in this form. One of the functions of Lubridate is make date time. So let me just, looks like this, make date or make date time, and it allows you supply individual components, combine them into one as either a date or a date time as the case may be. So using the flight data set, we want to combine these four variables, year, month, day, sorry, these five variables into one as our date time. So first we supply the flights data set, and then we select the columns we're interested in, that's this five, and then we use a mutate function to combine all four into one new variable called the departure variable. So if we run this, we will notice that we have our year, month, day, hour, minutes combined into one as a departure. So like this, and all the way down in all our rows. So that's how the make date time function works. There's also a make date function that only accepts date elements rather than date and time elements. So if we run this, we get similar results, but the time component has been dropped. So we just took the year, the month, the day, and combined them to give us one date. And also, if you notice, the format here is date, while here it was date time. This is the format of date time. So, like I said earlier, because of the complexity of working with dates, it can be quite tricky. It can give unexpected results, but what to do is to identify your needs and know which function will give you the desired output. So, for example, if I had been supplied this and I wanted to get a date out of it, and I would know that okay, I would need to use the make date format, make date function, and supply the necessary variables. So that's another example of how to create dates using the Lubridate package. One other way is to convert. You can convert dates to date times and date times to dates. So for example, if we run today, it just gives us today's date. But when we wrap it in this as date time function, it gives us the date and convert it to a date time. Now, because we've not supplied any time specifically, just add the time zone. Now, if we run the now function, it gives us a date time. If we wrap it in as date, it drops the time component and just gives us the date. So you may have a data set with a date time column. I want to convert that to simply a date column. That's also possible. That's also quite possible depending on your needs. Okay, so that's how to convert date times to dates and dates to date times. So as a quick example, I have, okay, another example. This is just the year, month, day, and it gives us an idea of what happens when you supply something that isn't a date. So we've supplied a string here that cannot be converted to a date, and the error message is one failed to parse. So if you have a data set that contains dates and one of those doesn't follow the format, this is the error you'll get. So as a quick example, we have some strings. I want to convert them to dates. So for example, D1. D1 is January 1, 2020. It's a string. If we the character string. So if we wanted to convert this to a date, we would use the month, day, year format because we have January 1st, 2020. So it's the month, the day, and then the year. And then we'll just put D1 in there and we have our date. So let me create date D1. If you check the class for this date D1, you can see it's a date. So same thing for D2. If we wanted to convert D2 to a date, we would use the year, month, day because we have the year first, then the month, and then the day. So it's quite intuitive how to create these dates from strings. And sometimes you may wonder why you need to create dates from strings. I mean, it's the same. It looks almost exactly the same. We have 2015, 03, 07. That's 2015 March. But sometimes you may need to carry out calculations with dates. You may need to find out the duration between two dates. You may need to add dates, add the duration of time to a date, and things like that. So that is something you can't do with a string. And storing this information in its appropriate format helps you down the line in carrying out these calculations. So third example, we have the day, the month, and then the year. So that will be DMY. And if we run it, DMY D3, we get our date again. The fourth example. Okay, the fourth example, you can have vectors of dates, of strings that are dates, and you want to convert those to date objects. So another useful thing about the Lubridate functions is that they will go through each component of the vector and convert each one to a date. So for example, in D4, we have a string of two a vector of two strings, which can be converted to dates. So we have month, day, and year twice. So all we do is just month, day, year, D4. You notice it converts both of those to two separate dates. Now, one drawback is that if you have a vector of strings and they are not all in the same format, for example, this month, day, year, the first one, the second one is also month, day, year. If I created the third one and put day, month, year, for example, let me say 1, 9, 15. Now, when I try to run it, we get one failed to parse because the month, day, year function is looking for the month in the first component of each string. So when it gets to this one, and it doesn't get a month here, it creates a problem. So that's why I said it's important to be um, extra attentive to detail when working with dates, because sometimes, okay, let's say this was in a format like 1/1/2015, oh no, 1/4/2015. When you run it again, you see that it works, but the output may not have been what we intended. So now we have the month first, day second, and then the year. So what it's doing is it's converting this to a month, this to a day, and keeping this as a year. But what if we intended for this to be a day and this to be a month? So this can be 1st of April or 4th of January, as the case may be. So it's extra important to be attentive to detail when working with dates, because you can have unexpected outputs like that, and that will really mess up your work or your analysis. So that's just an example of working with vectors. So we have D5, which is simply another string. This is a, okay, so 12, 30, 14, that's month, day, year, D5. And it works. So that's just a further example of converting dates using, converting strings to dates using these functions in Lubridate package. Just as a recap, they come in different forms. You have year, month, day, day, month, year, day, month, almost in any order you can imagine, month, year, day, as case may be. So it just depends on what needs you have and what format the data comes in. So moving on, it's possible sometimes to, you may need to extract individual components of a date. So I've created a small example here. You have a date time, which is a date and a time. We created that variable called date time. So now let's say we wanted to find out what year is contained in date time, 2016. If we change this to 2020, we'll run it again, we extract the year 2020. So these functions allow you to extract individual components from a date or a time, or sorry, from a date or a date time. So there are year, there's month, there's day, there's weekday, there's year day, and so on. So there's also month day. So year gives you the year, it extracts the year from the date, time, or dates. Month extracts the month. Day extracts what day. Weekday extracts the what day of the week it is. Year day extracts what day of the year it is. So month day, what day of the month. So as an example, now from our earlier date time example, if we run month date time, it gives us the month. Now by default, it gives you a numeric value, but an optional argument to the function is the label. So if you supply the label argument, it converts that numeric value to a text value that is easier to understand. So for example, if you run this and set label to true, it gives you July, which is the 7th month, and it also gives you the levels. So we also have month day. So what day of the month is it? It's the 8th day of the month, and you can see that's the case here. So it's, you may need to extract labels from, but not all of the functions have labels. So the label usually comes in where it's intuitive to have a label. So for example, month, there are 12 months, so we already know that one of every number will represent one month individually. Now for month, the label may not be so useful because they repeat. So in each month you have multiple Mondays, multiple Tuesdays, multiple Wednesdays. So it's a bit unnecessary to want to know what day of the week. Um, if you need to know what day of the week specifically, you could use weekday, which will give you a single numeric value. And if you supply the label argument to weekday, you get what day of the week it is. So it's a Wednesday. So the day of the week that this date fell on was a Wednesday. So what day of the year? If we run year day, it tells us, okay, the 8th of July is the 190th day of the year, at least for this year, and so on. So these functions are useful when you have certain questions you need to answer about a date or date type. So let's say you wanted to know what day of the week each of your dates fell on. Let's say you have a vector of dates. I want to know what day of the week each date falls on. You can supply the vector to weekday and run it, and it will give you your answer. So like I said before, it's also possible to add or subtract dates. That's one reason why it's very useful to store your data as whole dates instead of strings. So for example, let's create a HH variable and supply it this. Okay, so before we do this, let me just comment it out. Okay, so HH holds today. If we subtract that from year month day, we have a new. So when you subtract dates, you get a time difference. So for example, we have HH, we subtracted today from this date, 14th of October 1979. So what that gave us was 14,769 days. So this is just an example, but it may be useful sometimes when you're working with dates to find out the interval between two dates. So let's say you had a start date and an end date, for example. You have a data set containing start dates, end dates for a study, and you want to find out the intervals between those dates. You can simply subtract them like this. The as duration function converts durations to seconds. So it's, for example, we got the difference in these two dates. Let's say we wanted to convert them to seconds. We could use as duration. So as duration converts whatever time difference you supply to seconds. So we know that 14,000, from this we know that 14,769 days is this number of seconds and approximately this number of years. So other functions, you may need to supply durations. So these are called durations. Now, durations are all in seconds, and they are helpful for, say, you want to add a fixed duration of time to a certain. Okay. So let's say we have today plus so or rather, so these durations, they allow you supply fixed amounts of time, and they can allow you add, subtract, or basically work with dates. So let's say, for example, you wanted to find out what is today's date plus 5 days. You could supply with this. Now each of them starts with D, like duration, seconds, and then in parentheses you supply the number of seconds or the number of minutes, or the number of hours. So let's say we wanted to add 5 days to today's date. We could just say today plus b days 5 and get 5 days plus today's date. Today is the 21st plus 5 days, that's the 26th. So there are situations where you may want to add dates or times to a specific date, and these durations allow you to do that. Now, periods are similar to durations, but the difference is that in durations, everything is supplied in seconds. So if we run d minutes, we see 600 seconds, approximately 10 minutes. If we run d hours, we see in seconds first, then approximately the hour value. But with periods, durations are base hour, periods are Lubridate functions. So periods have a more precise manner. So for example, 15 seconds is 15 seconds, 10 minutes is 10 minutes, 0 seconds. In hours, it's the hours, 0 minutes, 0 seconds. In days, it's that. In months, same thing. So with periods, it doesn't convert the time interval you've specified. It doesn't convert it to specific second values. So it gives you the value in what you've supplied. So if we run days, it will give you 7 days, 0 hours, 0 minutes, 0 seconds. While if you run that same thing in a duration format in base hour, it will give you the second value. So 5 days is approximately this number of seconds, or rather this number of seconds is approximately 5 days. So that's sort of the difference between duration and period. And the reason for the difference is that the periods are more. Okay, so if I want to add 10 minutes to a certain time using periods, let's say now plus 10. So if we run now, we get this 10:42:18. If we add minutes to it, 10:52:23. Time progresses, so we can't pause the time. But anyway, you notice that between this is basically 10 minutes. Now, if we did the same using our durations, so now plus 10, we get a similar result, but this adds seconds and this adds minutes. So depending on what you need, it may be more helpful to use a duration or a period, as the case may be. And the differences become more. Okay. Sorry for the break once again. Internet issues. So, like I was saying, basically durations add seconds, periods add more specific amounts of time. So now, the thing about working with dates, like I've been saying, most of it can be a bit abstract. It can be hard to really grasp unless you try working with it. So at the beginning, I supplied this. Now this contained a data set. Okay. Oh, oh, oh. Okay. Sorry for the breaks. I'm having some internet trouble. Like I was saying, so flights is a data set that contains a record of every flight that departed from an airport in New York in the year 2013. So the first 4 components, or 3 or 4 or so components, are dates. So you have the year, the month, the day the flight departed. Then you have which are all stored as integers, by the way. And then there are others like the hour and the minutes. which are stored as doubles. So it's a useful data set if you want to practice working with dates and times and things like that. So I think it's one of the best ways to learn about working with dates is by using this data set or any other data set you can find that has a lot of dates in it. So moving on, we've spoken about durations, we've spoken about periods. Another thing is intervals. Now, the last thing we'll talk about is intervals. Sometimes you want to find out the specific difference between two periods in time. So to do that, I've added a year to today's date to create a variable called next year. If I run it, you'll see our next year is exactly 1 year from today, which is the 21st of March 2021. Now, if you wanted to find out how many um, okay, if you want to find the interval, how many days are between today and next year, we can, to be more precise, we can use this operator right here. So what this operator does is it gives us the interval between today and next year, and we are dividing that interval. If we run just this, just quickly, we run just this, we get our two dates side by side. So this is like from today's date with these two dashes, that's to next year's date. And we can divide that by the number of days to get how many days specifically is in that interval. So if we wanted to find out, let's say we added 1 month, I want to find out how many days, 31 days. So this allows us to get a more specific idea of how many days or how many weeks or how many, for example, if we divided this by weeks, or how many weeks as the case may be between 2 days. So that's a basic overview of working with Lubridate. Um, like I said before, it's not a part of the tidyverse in itself. You have to load the package. You have to install the package. For those who don't have it yet, install the packages. So you run this, you can install the Lubridate package, and then you load it within library. And we've gone over the different ways you can create dates and date times, either from strings, um, from from individual components, like this example we did with the flight data set. Also from others, so you can convert a date to a date time or a date time to a date. We went through some examples of doing this. We also spoke about extracting individual components. So you can extract the year, the month, the day, the weekday, the year day, or the month day from the date time or date. We also spoke about durations, periods, which you may want to add or subtract from dates, and intervals, how to get this specific interval between two dates. So that's the basic overview of working with um, the date package. It's quite helpful to work with it as to try working with it so that you get a better idea of how it works. Um, if there are any questions before we end the lesson, we'll take those quickly. So you can just send the questions in the chat window if you have any. I guess we'll wait for a while to see if there are any questions. Okay, seeing none, I guess we'll end here today till next week. Thank you all for attending. I'm always available to answer any questions on the page. Have a good day.